Okay, so section 2.6 is called special functions, which are just going to be functions that look a little different. So the first one is an absolute value function. So remember that absolute value is always positive. So when you graph an absolute value function, it just has absolute value bars in it. This is what I call the parent graph because it's just the absolute value of x. And it's always going to be a V-shaped graph. So when you graph the absolute value of x, think about if you make an XY chart here. If I pick -1, then my y value is going to be the absolute value, right? Remember, some people are struggling of where do I get these values. So back when you very first start this is like y equals the absolute value of x, and then this is your y value. I don't really show this step usually, but if you're struggling of where I'm getting these values, it's because I plug -1 in here for x, and then that would be the y value of 1. If I plug 0 in there, that's like saying the absolute value of 0, which is 0. If I plug 1 in there, it's like saying the absolute value of 1 is 1. So then these are my ordered pairs. So when I graph this, at -1, it's at 1, at 0, and at 1. And if you think about it, at 2, it's going to be 2. At 3, it's going to be 3. So it's going to look like just a straight line going like this. And at all these negative x values, it's also going to be a positive value. And so that's how we get this V-shaped graph. All right? This is the parent graph, which means when we do all the transformations, it goes from there. So the domain and the range of this. Well, just like a linear function, the domain of this, think about x can be anything. You can plug in negatives, you can plug in positives, you can plug in fractions. So the domain is all real numbers, or -infinity to infinity. But the range is what are the y values? What kind of y values do I get from this? Or if you look at the graph, the only y values are positive, right? There's no negatives here. So the lowest y value is right here, which would be 0, and then going up forever. So I'm going to say 0 to infinity. Or if you like set notation, you have to say y, because range is y's, and it's everything greater than or equal to 0. So you can do either one of those. I like that notation. But you need to know absolute value. So then if I do, what if I say do the absolute value of x minus 3? Well, you can pick some points here. So let's label our graph here a little bit. The big idea on an absolute value graph is you want to find that point where it turns. So here's my big hint, okay? And as we talk in this chapter more, we'll figure out more. But you always want to start with what makes this go to 0. That's going to be the V, the turning point in your graph. So I'm going to pick 3 in here, because if I pick 3, then I get the absolute value of 3 minus 3, which is 0. And then let's just pick some around there. So if I pick one more than that, like 4, that would be the absolute value of 4 minus 3, which is 1. If I pick 5, that would be 5 minus 3, which is 2. And if I go the other way, if I pick 2, then 2 minus 3 is -1. But remember, absolute value means that it's positive. And so once you get that these repeat themselves, I think that's going to be our shape. And so that's why it's so important that you know the shape of the graph. So 2, 1 would be 2 on the x, 1 on the y. 3, 0, 4, 1, 5, 2. And again, if you know the shape, as soon as you see where it's turning, you can graph that. What would the domain and range of this be? Well, the domain is still all real numbers because all the x's are used. And think about the last one. It started over here, but is the range on this one still the same? Yeah, so I'm going to say 0 to infinity, or you can say y such that y is greater than or equal to 0. Because it didn't move up or down any, right? If it moved up and down on the y-axis, then the range would change. Okay, step functions. So a step function is a floor or a ceiling function. Those are kind of the two things that we want to talk about. And so it consists of line segments arrays that look like steps. One type of step function is called the greatest integer function. It's a special case, okay? And so, why won't this work? I can't get this to work. I want this move. Oh, there we go. And so I call those also floor functions. because it rounds down, okay? So one way that you can write it is you can do it like this, because it has a floor on the bottom. But your book uses this double bar instead of this. So you just kind of need to know that that's the same as if you wrote it like this, okay? So it's kind of a couple ways to do it. Those are not absolute value bars. That's why that they kind of look like this. And I'll show you in the textbook in class what that looks like, all right? What you need to know is what that means. It means that it's the greatest integer less than or equal to that number, which means it always rounds down to the next one. So if it's an integer, it's just that number. So at 7, I get 7. But at 7.3, it rounds down to the closest number, which is 7. Negative 1.5 is going to round down to negative 2. And even though 2.9 is so close to 3, it always rounds down, so it's going to round down to positive 2. So what does that mean when we graph this? So I'm going to mark this every other one so it's not so squished. So I'm going to make this be 1 and this be 2. So if you ever make your graph not go by ones, you need to make sure that you label it so that I can see what you're going by, right? I can't read your mind. And once you label a few, I get the idea. But let's think about what this is going to be when I graph this. So think about, if you just pick like 0, you're going to get 0. I'm going to leave some space in between here. If I pick 1, I get 1. If I pick 2, I get 2. Which means that all the integers, I am just going to have a solid circle, like 0 and 1 and 2 and 3 and 4 and 5. But what makes this not a line is all the ones in between it. Think about every number between 0 and 1. Like if I picked 0.2, that's going to be 0. If I pick 0.7, that's going to round to be 0. So every number between 0 and 1 all give me a y value of 0, which means this is definitely not a one-to-one function. So I'm going to say, how do I show that on my graph? I'm going to draw a little line or a step. It's why I call it a step function. That every number from 0 to 1 is going to round back to give me 0. And the way we show that it doesn't include 1 is an open circle. And then what happens at 1? Well, it jumps up here. And then every number between 1 and 2 rounds back to 1. And every number between 2 and 3 rounds back to 3. And if you just know where it starts, you just kind of follow the pattern, which I know that kind of goes off my graph. And the same thing works for the negative. At negative 1, it's going to be negative 1. But every number between negative 1 and 0 is going to round down to negative 1. And at negative 2, it's going to be negative 2. And you can't put a line on this, an arrow to show that it goes on forever. So you got to fill your whole graph up, okay? And it looks something like this, which is a very new type of function. Think about the domain on this one. The domain, you can pick whatever you want for x. Yes, all the x's are used, which means it's all real numbers. But what are the only kind of numbers that I get over here in the y values? Well, I only get integer numbers, right? If I plug negative 1, I get negative 1. If I plug negative 1.5, that's going to round down to negative 2. These are only integer values. So to say that as a range, you can't write it in interval notation. This is one that you have to write in set notation. So I'm going to say all y's such that y is an integer. Or if you want to be really fancy, the letter we use for integers is z. So you say y is an element of the integers. And that means the same thing as this, but you can totally just write that it's just the integer values. That's definitely a special function. Just like with absolute value, they can be changed. So I want you to graph this one and see what's different about it. What does this plus 3 do to it? And we'll do that one in class after you do it. And then the other type of function is, instead of rounding down, one that's more real life, is a ceiling function, and it rounds up. So notice the difference that it has the arrows on the line on the top. It rounds up, and most things in life that we talk about charging per hour or charging per day, it rounds up. So if you rent a car for a day and a half, you're still going to get charged 2 days. Or if parking is per hour and you stay there 2.5 hours, you're really going to get charged 3 hours. That's a ceiling function. So notice that it looks very similar, except now the open and the closed circles are different. That's how you know the difference between these, because now everything between 0 and 1 rounds up to 1. Everything between -1 and 0 rounds up to 0. So this one's rounding up. The domain of this would still be all real numbers. And just like the floor functions, the range is only going to be integer. So I'm going to say where y is an integer. Okay, I know this is a new concept, but we'll work on it in